Okay, so as far as graphing this, to the left 3 units, if the original, I'm using pencil so I can erase, the original is at 0, then this one is going to be to the left 3 units. So just move this vertex over 3. And I'm just kind of showing you the parent function, but we aren't actually going to use that. So we moved it over to the left 3 units. And then graphing this, it's just a slope of 1. There's no coefficient here. So a equals 1, meaning up 1 over 1. So up 1 over 1. And the reason why I said over 1 instead of to the right 1 is because for absolute value, you go up 1 over 1 in the other direction as well.
Why is A1?
Why is A1? Because there's no coefficient there, so it'd just be like 1 times that. And then domain. So domain would be all the x values. It goes out forever and ever this way and out forever and ever that way. So domain is negative infinity to infinity and beyond. Range is the y values. Our lowest y value is at 0. It's a closed dot there, so 0. And then the upper range, it goes up forever and ever, so to infinity and beyond.
What does A stand for?
A is the slope in this, well, they call it stretch, but what do you know by the slope? They don't call it slope because slope usually goes in one direction, but it's going this way too. So in our case, 1, so up 1 over 1, up 1 over 1. And it was in the general form too, that A. So like I said, I'm kind of going over plays. As we practice it, it'll get easier and make more sense. And
Bracket on the 0?
what's that?
Is it a bracket on the 0?
Yes,
Okay.
Why is your bracket on
because it's got a point there. It includes that number. Yeah. Okay, next. So plan is to go through these notes today. It won't take very long. And then on Monday, we're going to practice it more. Like there's even more problems on Monday. So just kind of introducing, and then we'll get really good at it on Monday as well. Some of you might feel good at it today. I guess we'll see. Number 2, y equals x squared minus 4. That x squared means that we're working with a quadratic now. And a quadratic looks like this, and for the parent function, this point would be right at the origin, which is 0. So for this equation, we're looking at how this is transformed, or how it's moved compared to that parent function. So here, the x squared is by itself, and then it has the minus 4, so that would be right here, minus k, so we're going to shift it down 4 units from the original. So if the original is at 0, then this one would be at minus 4. 1, 2, 3, 4, right here. So our transformation is down 4. And now as far as graphing it, we can't just like pull the slope out. It's a little bit different. We're going to set up a function table. I'm going to put in the numbers 1, 2, and 3. With these numbers, I'm plugging them into the equation to see the output. So plugging in 1, so it would be 1 squared minus 4, which would be 1 minus 4, which is negative 3. I plug in 2, 2 squared minus 4 would be 0. 3 squared minus 4, 9 minus 4 would be 5. So now I'm going to graph these numbers. So 1, negative 3, 2, 0, and 3, 1, 2, 3, 4, 5. There. I could list out negative 1, negative 2, and negative 3 to get the points over here. But honestly, when you plug in a negative 1 here, negative 1 times negative 1 is going to be positive. Negative 2 times negative 2 is going to be positive. So it actually ends up being the same points on the other side. You can just reflect it. Reflect these points over.
Real quick, how did you graph it with the those numbers you got? Is it just?
I just chose random numbers.
Yeah. What, like, how did you? Is it 1, -3?
Yeah,
Yes.
that's,
That
yep,
one.
those are the points.
So for the other side, would you just plug in?
You could plug in, so it just reflects on the other side the same thing. You could plug in -1, but you're going to get the same output.
Will it always be like that? Or?
Yeah, but the only thing is it's not always reflected over the y-axis, and we'll see that example in a second, like in a minute. And then domain, this will continue kind of going out this way, and range, and it'll continue going out this way. So domain is -infinity to infinity. And for range, the lowest y value would be 1, 2, 3, 4. So put a bracket on 4, and then up to infinity and beyond.
How do you know that it includes 4?
Equal. Yep. 3, now we have absolute value symbols. Absolute value function. With the absolute value, the parent, like it looks like, it's going to look like this. For the parent function, it would just be, the vertex would be on 0. So on this one, it has a negative. And looking over here at our rules, when we had the negative out front, reflect across the x-axis. So that's what we're going to do. Reflect. Or I'll just say reflection, and it reflects across the x-axis. So the center there is still at 0. The only difference, instead of going up 1 over 1, we're going down 1 over 1.
And that's because it's -x.
Yep. So it's like -1 down 1 over 1. And then domain, for the x's, it goes on and on forever to left to right. So -infinity to infinity. And then range, it goes down forever. So starting at -infinity. And then the highest y value is 0. So up to 0 and bracket. Next. Okay, so those are pretty simple. The next one's same idea, it's just it combines different parts of the transformation. So number 4, we have the absolute value symbol, so it's going to be an absolute value function. So it'll look like this. That's supposed to be straight, but you get the idea. And then there's different parts here. First, I see this coefficient of a 3, which we know is slope, and it is kind of, it is like slope, especially in absolute value, but they call it a stretch of a 3. So stretch 3 times. And then here we have the +4. Looking at our chart, +4 is to the left 4. And then we have the -1 at the end, so that means down 1. That says left 4, by the way. So stretch 3 times, left 4, down 1. Yes,
How
Haru.
do you find this out?
Looking at this, that coefficient, that 3, it's like a slope, but they're calling it stretch because it doesn't just go like, you'll see in a second. Then left 4 and down 1 is from this over here. So plus h, that's left that many units, so I put left 4, and then the minus k, that means down that many units. As far as what this means, these have to do with that original point. So this moves the vertex. And then this changes the line. Again, we're just like going over plays. Until we practice it a bunch of times, it's not going to seem like super simple. Not it. Yes.
How do you know like which numbers are H and K?
So going back to this format, the general form, this one right here. Yeah. Okay. Next. Okay, now we're going to plot our original point. The parent function would be at 0. Just kind of sketching that out. I'm going to erase this pencil mark. Parent function would be here. We have to move this origin to left 4, down 1. So from this 0 to left 4, 1, 2, 3, 4, down 1. Right here. Let me erase this. Then we have a stretch of 3. What that means is up 3 over 3. Or up 3 over 1. 1, 2, 3 over 1. Up 3 over 1. Just like you would do a slope. But with absolute value, it's also going to go in the other direction this way. So up 3 over 1 in the other direction. And then connect your dots. Like that. And domain, it would continue going outwards in both directions. So domain is again negative infinity to infinity. And then range, the lowest y value is negative 1. So negative 1. And it continues going up to infinity. Next, this is a 2. I don't know how to print it on yours, but that's a 2. It's a quadratic. So it would look like this. The parent function would look like this, and then this would be at 0. Looking at these numbers, we have a negative coefficient. So that negative means that there's going to be a reflection. The 2 is the stretch, so a stretch of 2. And then this minus 3 means to the right 3.
How did you get stretch 2?
The coefficient right there, 2.
How'd you get the reflection?
The negative.
Of the 2?
Yes.
Oh.
So the negative's for the reflection, the 2 is for the stretch, and the minus 3 is to the right 3. Okay, so if for a regular, the parent function, it would be at 0 and it would look like this. So it's going to be a reflection, so it's going to be actually facing down. And then to the right 3, so 1, 2, 3. This is our origin right here. Right here. Okay, so now how do we find our points? I kept referring this as kind of like a slope, and it is kind of like a slope, especially with the absolute value, but it's a little bit different with the quadratic. We're actually going to make the function table and get the exact points. So the points we're going to use are just 4 and 5.
How did you determine which numbers to use?
You could do random numbers. These were just chosen because they work out well for this problem, but you could just choose random numbers. So then plugging this into the equation, (4 minus 3 squared would be 1. 1 squared would be 1. 1 times negative 2 would be negative 2. So your output's negative 2 for that. And then for 5, 2 squared, 4. 4 times negative 2, negative 8. And I'm going to plot these points. Like this. But as we know, quadratic goes down on the other side as well. And there we go. Then domain, it would continue going outwards ever so slightly forever and ever. So we get negative infinity to infinity. And then for the range, the lowest y would be negative infinity. And then the highest y would be 0, bracket. And last but not least, we have this absolute value. So our graph will look like this. For the parent function, this is at 0. For this one, it doesn't say like it's left or right or up or down, so our origin is at 0 for this one as well. But this 1/3 is called a compression. Why they call it that, I don't know, but I'll show you what it looks like.
I always heard strength.
You always heard what?
Strength. Like
Vertical
vertical strength.
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 What?
Strength.
How do you spell it? Shrink.
Yeah.
Huh. I don't know if that would work either. I'll show you what I mean. So this would be the 0. Then it's absolute value, so it's going to go like out in both directions. And so 1/3, we go up 1/3.
Wouldn't that be a stretch?
That's what I'm saying. It looks like a stretch to me. Maybe because it's like compressed downwards, like flattened. And domain, negative infinity to infinity. Range, our lowest y would be 0, and it would continue going up, so infinity. And we're done. Okay, so the last 15 minutes, I'm giving you to either redo your homework from last night that you didn't do well on, or maybe you did. Some people did well, just some people didn't, or gave up, or whatever. So hop back on your homework from last night, get a good score. If you have questions, let me know. And work on your Khan Academy for the end of class, because Khan Academy is due tonight. Yes, you can get your phones. If you need to use restroom, you can.
Can you